going to split my page here, and what we do when we run into a question like this is we're going to have to do some thinking, some problem solving, some ideas, and then see what happens, okay? So I'm actually going to go down 2 rabbit holes that appear not to work. And then I'm going to go back to the strategies that I thought about and then see where it can go from there, okay? So strategy number 1, okay, I am going to look at this question and I am going to be somewhat influenced. Have you ever been influenced by the type of questions you've been doing? Oh, this is under completing the square. Well, that's what I should do because it's under that. So I'm going to take the x squared plus 6x plus 13, leave a space here, saying, I know this will work out nicely to be x plus 3 squared, which means I'd have to add 9 here and subtract 9, because the only thing I'm allowed to add to an equation is 0. And as a result, I get plus 4. Well, I said I was going to do that in purple. This will be the method in black. Okay? So we start our method in black, and now I have the integral of 2x over x plus 3 squared plus 4 dx. And things are looking okay, except I have a problem. Okay? First of all, I'm off to the side. I am thinking about my integral of 1 over 1 plus x squared dx. I'm thinking about this integral, but I have a problem at this moment. Thank you. In that that integral has a 1 on the top. And my integral has a 2x. If it was a 2 on the top, no problem. But that extra x is a problem. Ugh. So I'm going to not like this for a moment. I mean, I could really get it close, right, by factoring out the 4. If I factor out a 4 on the bottom, I should just do that a little bit slower. I take out the 4 on the bottom, leaving me with 1/4 there. Yes, that's why I should do it slower, so I don't make mistakes. Plus 1. So that 1/4 could come out in front. I could even bring the 2 out in front if I wanted to. So I've got the bottom matching up with my tan inverse like I wanted to, but I have an issue with the 2x on the top. Blech. So I do all of this work, and this will happen to you sometimes, and feel like I don't know if I want to keep going with this method. So I put that method on pause. I congratulate myself a little bit, say, Mr. Jerry, you did some good math there. I'm really proud of the algebraic manipulations. You've shown you know a lot of stuff. And you gotta, some of these you've got to encourage yourself as you're going along, because otherwise you might just quit, right? So if you're quitting on questions, you need to practice encouraging yourself, because you can and will be able to do this, okay? Oh, this wasn't working whatsoever. This is the next part that's hard for you, is to abandon the original method that you were doing and try something else. By the way, we could keep going on this method and eventually create something that may work. But maybe we'll go back to that in the end. Okay? Probably at this moment I would be like, dude, I don't like what's happening. The nice thing is on your final exam, they're not going to put this under the completing the square method technique. So you're not going to be biased. You'll probably try another technique a little bit earlier. So a second technique, I'm like, oh, well, I know that the derivative of an x squared is an x. In fact, the derivative of x squared is perfectly 2x. So I might start to think that substitution would be nice. So I let, this time I'll go purple. Purple method, I let u equal the whole bottom. And usually when we substitute u in for something, we do like to substitute it in for everything in that spot. So that I'm like, oh, if this was a u on the bottom, I'm thinking natural log of e. Right? Because if I have a 1 over u, I get a natural log. Okay? So it's really important that we also have all of our integrals and derivatives well memorized so they kind of guide us in our problem solving. So I'm like, okay, well then du would be 2x plus 6 dx. And at this point, I'm kind of frustrated with the purple method. Because I have the 2x, but I don't have the plus 6. Okay? So both methods are causing us some problems. And both methods have actually have solutions working forward. Okay? I'm going to show you ideas for the solutions working forward for both of them. But I'm going to show you what you could do with the purple method first. Because I believe that following through with the purple method is a little bit easier than following through with the black method. And we come to an idea in math that's brilliant. Mathematicians in higher level math do this all the time. Their brilliant idea is, I'm going to add 0 and see what I get. Or, I'm going to multiply by 1 and see what I get. Now this is a brilliant mathematical strategy because it takes thinking that a kid in grade 1 would be like, well, that's useless. Like even in grade 1, right? What do you get? 3. Well, I got 3 plus 0. They're like, you're dumb. Right? 3 plus 0 is the same as 3. Or I got 3. I got 3 times 1. That's the same thing, right? But what we can do in mathematics, so here's our purple method. I really, really, really want a plus 6. Wouldn't that be nice? So I just get it, right? We're spoiled calculus kids. You want a plus 6? Just ask for it. You get it, okay? But it's going to cost you something. What's it going to cost you to get that plus 6? You're going to go into debt. You're going to owe me later. So you're going to have to do a minus 6 at the same time. And what we have done is just added nothing. But now we can unadd our fractions. And unadding our fractions, I can split this up so this one works out so nice with my plus 6 and x squared plus 6x plus 13 dx minus, and I'll do the other one with just the 6. And the nice thing about this is that rabbit hole number 1 is still useful for rabbit hole number 2. Do you notice now this works out perfectly with our substitution, the first part? Back, if I change it, right, look at what I have. U is x squared plus 6x plus 13. Du is 2x plus 6dx. This integrates beautifully to just be 1 over u du. The second one, now I can complete the square because I don't have that x on the top. And I've done that work. In fact, I'm going to put I technically did all of that work here with the 2x on top. Can you see if you did all of that work with the 2x on top, it would be the same as doing all of that work with the 6 on top. So I'm going to minus. I'm going to have that 1/4 out in front. I'm also going to pull out the 6 out in front. And this then would have simplified to x plus 3 over 2 squared plus 1 dx. And off to the side, I am going to let v equal x plus 3 over 2, then dv would be 1/2 dx. So first of all, this is just the natural log of the absolute value of u plus c minus 6 over 4, may as well reduce that to 3 over 2. And here I'm going to change this to 1 over v squared plus 1 times 1/2 dv. So I'm going to get natural log of absolute value of x squared plus 6x plus 13. This half can come out in front, so I'll get -3/4. And now this matches up perfectly with tan inverse of v, and of course v was x plus 3 over 2 plus c. Whew. That's some complicated problem solving in that question. Okay? Now, if you had gotten to the black section, so I think the purple section is the easiest. It's by no means easy. We should be careful when we say easiest. It's by no means easy. However, if you have, right, some things that we need to build into our repertoire to be able to recognize, right? How do I recognize the completing the square technique? Is when I have a number over a parabola, and that parabola is either on its own, because then it's tan inverse, or that parabola was inside a square root, right? We can go back to an example we did before. Oh, I have a parabola inside the square root. These are most likely going to be sine inverse and tan inverse integrals, and you're going to use your completing the square method, okay? So we are looking for patterns as calculus students, right? Because recognizing and naming patterns helps us, when we get to a question, choose the right rabbit hole to start going down, even if that becomes difficult as we're doing. So we're recognizing that whenever I have a number over a parabola, either in a square root or just on its own, it's probably one of these integrals. This one caused us a problem because we didn't have a number over it. Okay? So, if the bottom you can use substitution for, which we did, and the derivative of the bottom is on the top, or at least close enough. Okay? And this is the strategy for this part. If the derivative is close enough, just off by a constant, in this case the derivative was just off by the plus 6, we can always add 0. So adding 6 is what I wanted to make it work. I subtracted 6. Now when I broke it up, now I have one form which is perfect substitution, and the other one is the form of tan inverse. So even though it's still difficult from here, with the numbers makes it awkward with the 6/4 and the 1/2 and different substitutions, you should feel a sense, okay, and this is where I want you to be, is if we recognize patterns, we can get a sense of comfort and say, hey, both of these are in forms that I know how to do. Now I'm in a place of comfort. Even though the numbers might not be nice, I can work forward with both of those. And as long as I'm careful with my algebra and stuff, things should work out. Now, I had mentioned that the black rabbit hole actually does work. It's just a little bit more creative. So you would have done v as this substitution, but if you're doing a v with a substitution, you still need to replace the 2x with something. And so, can you see in this first part here, I could multiply both sides by 2 and have 2v equals x plus 3. So technically, 2v minus 3 would equal x, and I could substitute 2x. I can either pull the 2 out in front and substitute 2v minus 3 for x, or I could just go, well, 2x would be then 4v minus 6. And then I could do a substitution with the 4v, and you will end up with the same process here, where you're going to have to unadd fractions. However, I do think that the purple method is easier to see from the beginning, but the black method would work all the way through. Okay, so definitely a problem-solving question. And I worked through it as if we were stuck and had no idea, rather than, like, sometimes you'll see this taught, oh, you should just do this. Well, how would I think of that? And I want you to get that process of how you would think of that. And the main strategy is sometimes saying, what do I want? And then make it what you want. That's what we did with the plus 6 and minus 6. Okay, let's go to some trig ones and struggle a little bit with these ones. So again, split our page here. Okay, I'm going to write out from my identities every single place that I see a sine squared from my identities that I used to know. But obviously, sine squared plus cos squared equals 1. I could use a sine squared from there. I've also got, I could rearrange, right? I could rearrange my cos 2 theta formula. Cos squared theta minus cos 2 theta. Or I could also rearrange my cos squared 2 squared theta to be, right? Because cos 2 alpha is equal to 1 minus 2 sine squared alpha. There's another sine squared, so maybe I try and pull things out of there. So I would have 1 minus cos 2 alpha, 2x in this case, over 2. Now, I'm not sure if any of these will be super helpful or not, but it's nice to have them listed off to the side as a starting point. Thank you. You can recycle this. So what we can do, right? I can rewrite sine to the 5 as sine squared x times sine cubed x. I can rewrite it as just plain, or I can have sine squared x twice times another sine x dx. And obviously, I know that if I do a substitution with u as sine, then du would be cos. Or u as cos, then du would be sine. So I'm going to play around with things. All right, so I could change, wherever I have a sine squared, I could change it to cos squared. And then I'm going to think about things that I can do with u. Like if I made u equal to cos x, then du would be negative sine x dx. So I would have 1 minus u squared, and then I would have negative du. Could I do something with this? Right? This is the problem solving. Just writing ideas out and then asking yourself, could you do something with this? And the could you do something with this sometimes will come from experience because, oh, by practicing these and getting stuck and sometimes seeing a solution out of it, you'll say, yes, I could do something with this. But having never practiced them, you're going to get stuck. Okay? Now, technically, in this form, I still can't integrate that 1 minus u squared because I have a function inside of a function. Right? The 1 minus u squared is inside the squared. So if I did another substitution and said, let k equal to 1 minus u squared, well then dk would be 2u, and I don't have an extra 2u. But we can't forget that we also have algebraic techniques. Could you actually square this out? Absolutely. And if I square it out, and I think this is going to work, I feel like I'm ready to go to my solution. So I'm going with sine squared x squared sine x dx. I liked changing that to 1 minus cos squared x squared sine x dx, making u equal to the cos x, and du would be, well, negative du would be sine x dx. And what I like about this is that I can square this out, do some algebra. I get 1 minus 2u squared plus u to the 4, and pull that negative out in front, du. Or you could distribute that negative all the way through. It's up to you. Right? Either you could pull that negative out in front, or you could have that negative inside with all of them. Whichever you'd like. You're going to have to distribute that negative eventually anyways. So now how do we integrate each of these things? It's not hard. This is just going to be negative u plus 2u cubed over 3 minus u to the 5 over 5 plus c. And what was our u? It was cos. So negative cos x plus 2 cos cubed x over 3 minus cos to the 5x over 5 plus c. So what is the takeaway from this one for you guys that I would like you to keep in mind? Keep in mind your basic algebra from grades 9, 10, and 11. You are able to square something. Heck, you could even, if this was to a power of 8, you could use the binomial theorem and do it. It would be painful, but possible. And may be the best way to go about doing it. If they did that, oh my goodness. All right, if I saw that on your AP exam, I would give a little tear. Like, really? To the power of 8, the binomial theorem, right? But technically, this is the scary part, nothing you've ever learned is off limits. That's scary, right? Because you guys have a trash bin in your brains where you forget stuff. Like, ooh, as soon as it's done. You have some subjects that you've done, it's like, you finish the subject, like the whole history class. You dump it into that trash bin of, I'm going to forget this forever, right? Unfortunately in math, you're not allowed to throw any, you've got to become math hoarders. You've got to hold on to every bit of knowledge that you have ever learned, as it's coming back. So, I've done one. I will eventually post the solutions to these on your teams, but this is where, again, it's not helpful for you just to see me do it. You have to come up with a strategy of one that you're going to use. And you know what's the frustrating thing about some integrals? There are some integrals that are impossible. You could try them forever and get stuck.